Hi, my name is Jonatan Sastre from TTTechAuto. I'm here today to talk about the time-sensitive Network CNI plugin for embedded on Edge. I will start with an introduction and then I will proceed with the demo. So, determinism in Edge and embedded. Here at TTTechAuto, we work with time-triggered technologies, so determinism is very important for us at all levels. Automotive industry is growing and expanding its horizons towards the cloud. We identified the necessity of deploying workloads to different targets. For traditional automotive use cases, we can count on ad hoc solutions, but when considering edge systems, it is usual to find externally provided resources that rely on standard technologies. For example, container orchestration systems running in standard OS and standard network stack. It is non-automotive specific. So, why is CNI plugin? When working with containerized workloads, we were missing network determinism. TSN is one of the technologies we work with, and it will be great to have common tools that can be used as is in both worlds, embedded on edge. This is the reason why we created the CNI plugin for applying TSN policies to container networks. In this diagram, a couple of Linux machines are represented. In each of them, a container orchestration system has been installed and several containers have been deployed and assigned to a network. Typically, container system networks creates a virtual Ethernet pair and exposes one end to the network namespace of the container and the other end to the network namespace of the host. So far, nothing new, except the CNI plugin at the left, in orange. This plugin configures the network stack at container basis for enabling TSN. Interestingly, TSN policy can be enforced at software level, but also at hardware level when hardware offloading features are present in the physical network card interfaces, transferring the actual processing to the hardware for more accurate results. In this demo, we will present an example that sets up a pod consisting of a single container that it is assigned to a network that inserts our CNI plugin to the plugin chain. Network traffic generated inside the container will be captured on the host side. The traffic will be shaped according to the gate control list specified in the CNI plugin instantiation. Let's take a closer look into the process of applying TSN configuration to a container network. CNI-based container networks are created before any container exists. The container network configuration file consists of a list of CNI plugins that will be executed sequentially to perform predefined actions according to their position in the chain. When a container is created and it is assigned to join a network, the plugins are called and several actions take place, from creating the virtual network interfaces and configuring IP addresses to complex network operations. We designed our CNI plugin to be as less intrusive as possible. Such is the case that it can be just appended to the end of the CNI plugin list, and in most cases, it will enable TSN feature on the container assigned network. For our demo, QBB profile will be used. In the network configuration file, we have added our CNI plugin definition and have specified 3 traffic classes assigned to the dedicated time gates. 2 of the gates will be open for 1.25 milliseconds and the third for 2.5 milliseconds. Additionally, a time gate of 0.5 seconds with no traffic class mapping has been defined, so no traffic at all will be allowed during half a second. Traffic has been classified according to the UDP destination port. Here we can see a wireside capture after applying the previous configuration and sending UDP traffic to the destination ports 5001, 5002 and 5003. As expected, traffic class 3 has its time gate open for 1.25 milliseconds, then traffic class 2 for 1.25 milliseconds as well, and finally traffic class 1 for 2.5 milliseconds. As expected, no traffic is present until 0.5 seconds are elapsed due to blocking empty gate, we mentioned it earlier. Here we have a live demo. So we will be creating a container, and we will be assigned to a TSN network that includes our CNI plugin. Then we will be using IPERF3 in order to generate some UDP traffic, and we will have an IPERF server in the host, and we will be listening for the traffic. We will be also capturing traffic using TCP dump. So now we are sending UDP packets from the container. We are receiving it. We are receiving them in the host, and we are capturing all the traffic. So if we explore, we inspect this capture with Wireshark, we can see blocks of traffic according to destination UDP port, as expected. And for sure, the TSN policy has been respected. If we open the statistic for the network, we can see that we have some spikes, and we have no traffic in between these spikes for 0.0 seconds. This is because of this empty gate that we define. So we are blocking all the traffic during 0.5 seconds as expected. This is just for demo purposes, because that way it's very easy to identify this pattern in the traces. So we can proceed with the conclusion. So we can say that the proposed CNI plugin allows to enable and apply TSN policies, follows a non-intrusive approach for seamless integration with container orchestration systems, and that it is suitable for cloud and embedded, based on standard technologies, gets the most of its system features from software only or software only up to hardware offloading when available. And that's all. So thank you very much for your attention.